This is a video for Chem 1211 on net ionic equations or net ionic reactions. Let's, as an example, take the reaction between pyruvic acid and radium hydroxide. Now, I did not put states on these to start because this is what we want to consider. If this reaction is taking place in water, what would the predicted products be? Well, from the pyruvic acid, it's pretty clear that there's only one acidic H. So the radium would replace that. But the pyruvate ion is -1, so there would need to be two of those in the final product. What is that reacting with, or what would the other product be? Well, the H plus is kicked out, so the H plus would react with the hydroxides, and this actually means we would form water, and we would form two water molecules when that happens. That's definitely going to be a liquid. So what else do we need to do to balance the reaction? Well, we would need two pyruvic acids. What would the states be for all of these? Well, the pyruvic acid, it's a small molecule. It looks pretty polar. So if that's in water, that's going to be aqueous. What about the radium hydroxide? Well, most hydroxides are insoluble except for group 1 and heavy group 2. And radium specifically is the heaviest group 2 that we know of, so that's also definitely aqueous. What about the radium pyruvate? Well, if the pyruvate is from an acid and it looks kind of like acetic acid a little bit, then we should probably group it and think of it like it's an acetate. And so if we think of it like an acetate, then that means that acetates are soluble. And so we would also want to say that pyruvates are soluble. So that means that this radium pyruvate would be aqueous as well. So this is the overall bulk reaction. Taking this to write a total ionic equation. What's going to happen to the pyruvic acid? What kind of compound is pyruvic acid? If you said it's an acid, you're correct. And specifically, what kind of acid is it? Hopefully, you said it's a weak acid because it's not one of the strong acids you have memorized. So that means that that stays together. That stays together as pyruvic acid, and I'm going to use the chemical formula rather than the line structure to show that. What about the radium hydroxide, though? If you said it's an ionic compound, you're correct. And what do you know about that ionic compound and how it would behave? Hopefully you also said that it's soluble, meaning that soluble ionic compounds are strong electrolytes. So that means that we have radium ions and hydroxide ions in solution. Well, the water has to stay together because that's a liquid. But what about the radium pyruvate? Well, again, radium pyruvate now is an ionic compound. And so that radium exists in solution. And the pyruvate ions would also exist on their own in solution. Looking at the whole reaction, which ions or species are considered to be spectators? There's only one here, and it's the radium that's on both sides of this reaction. Meaning the net ionic equation, because everything else that's left has a 2 as the coefficient, that means that the net ionic equation is simply A pyruvic acid reacting with A hydroxide ion to make water, and the pyruvate ion. We would see something similar to this where we have a molecule that is not a strong electrolyte. This is a weak electrolyte. We would see something similar to this when we look at something that's an insoluble compound. What's an insoluble compound? Let's use something like iron 2 sulfide as our insoluble compound. Let's say that we react that with some hydrochloric acid. Well, looking at what we think would form, the hydrogen would replace the iron, meaning that the product would be iron 2 chloride and H2S. Since this takes place in solution and halides are soluble, that means the iron 2 chloride would be aqueous. But what do we know about H2S? We know that's a gas. In this reaction, when we write the total ionic equation, we would also keep the solid iron 2 sulfide together while splitting up the hydrochloric acid keeping the H2S together because it's a gas. So remember, the only things that can possibly split up are those that are aqueous, like the iron 2 chloride, which does split up into iron 2 and 2 chloride ions. Looking at this reaction then, what are the spectators? Well, there's only one spectator. Unfortunately, it's not balanced in this reaction. We would have had to have had 2 HCl, which would mean 2H plus and 2 chlorides. But then the 2 chlorides would be equal on both sides and cancel out as spectators. So the net ionic equation would be solid iron 2 sulfide reacting with 2 protons to form H2S gas and iron 2 ions. So notice that the species that are together that are not dissociated are not always only in the products. If you start out with a reactant that happens to be a weak electrolyte, then that weak electrolyte will stay together on the reactant side. And if that's the case, then you don't only have ions as reactants and you don't only have the single product on the product side.